Hi everybody, in this video I'm going to talk to you about how to solve simultaneous equations with fractions. So at this point we should be used to seeing a simultaneous equation that looks like this: 2x plus y equals 31, and 3x minus y is equal to 15. And we can add the y's to cancel them out, add the x's, and add the constants. So we get 5x in this case would be equal to 46. And from there we have an equation with one variable which we can solve out. So yeah, you can see here 5x equals 46. So in this example what we're going to do to incorporate fractions, we're going to look at an example where one of the equations actually includes some fractions in it. And that obviously makes it harder. So let's have a look at the actual question. So our question has two equations: x plus y is equal to 10, and this less friendly looking equation, x plus 1 over 4 plus y minus 1 over 2 is equal to 3. So fractions really are not our friend in algebra, unfortunately. So what we're going to try and do is rewrite this second equation in such a way that we don't have to deal with the fractions anymore. So I'm going to do this over to the side as rough work. Okay, so the way that we get rid of a fraction is the same way as we have previously gotten rid of fractions in algebra. We find a term that all the denominators, all the bottom numbers, will divide into. So we need to think of a number that 4 and 2 both divide into. In this case, the smallest number we could use would be 4. So what I'm going to do is multiply every term by 4. 4 times by x plus 1 over 4 plus 4 times our second term, y minus 1 over 2, is equal to 4 times by 3. And a common mistake people will make is forgetting to multiply the non-fraction terms, like our 3 over here, forgetting to multiply them by the number as well. Now, to save myself a little bit of hassle before I start multiplying out, what I'm going to do is just cancel those numbers with the denominator. So 4 divided by 4 actually cancels to 1, which makes life a lot easier. 4 divided by 2 cancels to 2. And over here, there's no denominator for it to cancel with. So what this means is for that first fraction, I only need to multiply that by 1, so it stays the same. 1 times by x plus 1 is x plus 1. For the second one, I'm going to have to multiply 2 times by y minus 1. And over on the right hand side, it's going to be 4 times by 3, which I can just simplify now as to being 12. I can do it later if I wanted either. Okay, so this is starting to look a little bit more friendly. We don't have the fractions anymore, our denominators, to deal with. But we do have to do a little bit of multiplication, and then it looks like we're going to have to simplify it afterwards. So let's multiply out the term outside the bracket. So 2 gets multiplied by y, and 2 gets multiplied by minus 1. We're not going to worry about the other terms yet because these have addition and so on. We're just going to do our multiplication first. So everything else stays the same. X plus 1 stays as x plus 1. 2 times by y is 2y. Then we're careful with the sign. Positive 2 times by a negative 1 will give us a negative 2. On the far side of the equation, we have just a 12. At this point now, we have an equation where we've gotten rid of our fractions. Any multiplication that needs to be done has been done. What we're probably going to do is just tidy it up a little bit so it lines up nicely with the other equation, x plus y equals 10. That means we're going to have the x and y term on the left hand side and the constant term on the right hand side. So my x term can stay where it is, that's good. My y term can stay where it is. Both of those are on the left hand side of the equals. What needs to move? See if you can pause the video now and identify what needs to move to the other side. Okay, so hopefully you identified that 1 and our minus 2 both need to move to the other side. Again, be careful. The term here is a positive 1, the term here is a negative 2. So x and 2y stay on the left side of the equals. 12 stays on the right side of the equals. And what's going to move over is our positive 1 and our negative 2. When each of those moves to the other side of the equals, it should change its sign. So we end up with a negative 1 and a positive 2 on the far side. All that's left to do then is simplify x plus 2y is equal to 12 minus 1 is 11 plus 2 is 13. So this is a lot of rough work to have to do. That's why I would always suggest doing this as rough work first of all, before you start into trying to solve the simultaneous equations together. So now we have a nice equation, x plus 2y is equal to 13. It is telling us the same thing as this is telling us, but it's just doing it in a much nicer way. So if we want to go back now and do the part we are familiar with, we're going to take this equation, x plus 2y is equal to 13, and we're going to use it in conjunction with this equation here, x plus y is equal to 10. So the second equation, we're just going to replace it with the much simpler version. So first equation says the same, x plus y is equal to 10. The second equation, we're going to write in its simplest form, x plus 2y is equal to 13. Now, we need to cancel either the x's or the y's. The x's already match, so I'm going to multiply across by minus 1 for that second row. So top row will stay the same, x plus y is equal to 10. Bottom row will be minus x minus 2y is equal to minus 13. Adding our terms together, x minus x cancels out. Y minus 2y gives us minus y. And 10 take away 13 is minus 3. So at this point, we could divide both sides by minus 1 if we like, or we could just switch the signs of every term. Lots of different ways of thinking about this, but essentially we end up with y is equal to 3. Just for the purposes of our work being clear to an examiner reading it, we're going to put a box around that because that's quite an important milestone in our question. Then we choose one of our two original formulas to make a substitution for. This top one is a simpler looking formula, x plus y is equal to 10. It doesn't have a coefficient or a number in front of y, so I'm going to use x plus y is equal to 10. A lot of people will forget the step of writing out the formula now. X plus y is equal to 10. We always write it out first, so we're less likely to make a mistake than if we just straight away substitute in a number. It also means if we do make a mistake, we'll still get a 10 marks for it. So x plus y is going to become x plus 3 is equal to 10. Y has become 3 because we know that y has a value of 3. If x plus 3 is equal to 10, we're going to solve it by keeping letters on the left, normal numbers on the right. So 3 will move to the other side. X will be equal to 10. When 3 moves over, it becomes a minus 3 because it was positive beforehand. So x is going to equal to 7. And again, we've solved for a variable, so we put a box around x here. Quick recap, everything we've just done is very similar to what we've been doing so far from this point onwards, where we have two equations and we're trying to cancel out one of the variables. We do that and then we're left with an equation for y in this case, solve for y, then go back to one of the original equations and substitute in the value we do know, which in this case y is equal to 3, and then we can solve out for the second equation. The extra work we had to do this time was solving out, as rough work, a simpler version of our equation that contained a fraction. So we did that by finding a number that both denominators divide into. 4 and 2 both divide into 4. So every term got multiplied by 4, including 3, which isn't a fraction. It only works if every term gets multiplied. So then we're able to cancel the outside number. 4 and 4 gave us 1, 4 and 2 gave us 2. We can cancel the outside number with the denominator and then carry out any multiplication that's left before simplifying it so that we have our x and our y on one side and our constant on the other side. This very unappealing set of fractions that made up an equation has now just been simplified to being a normal equation with no fractions involved. Then it could go straight into a simultaneous equation with the other nicer looking equation with x and y is equal to 10. I'm going to leave this here for you to take down as you go, but rewatch the video if you need to get more detail on any part.